Welcome to Simple Interest, Unit 5. This will be part 1 of a 2-part series dealing with simple interest. I'll talk about all the objectives for the entire unit in part 1 here, because the objectives are actually fairly streamlined. We're going to do a lot of practice, but there's not a lot of heavy substance here. So we start off with, we have a formula for calculating the amount, and by amount I mean dollar amount of interest. And we can kind of see in that little formula in part 1 or bullet 1, it's PRT. P stands for principal, R stands for rate of interest, T stands for time. And so how much interest we get paid is dependent upon how much money we put in, what the rate of interest is, and how long we put it in for. All kind of basic common sense stuff. We can rearrange that particular formula to solve for any one of the other little components. So we can rearrange it to solve for R, the rate of interest. We can rearrange this to solve for T, how long we're invested. Okay? Very similar to what we were doing in Unit 4. So nothing different there. We keep with the one formula. We don't try to memorize all sorts of iterations, but we understand with the basic algebra that we know from Unit 2 that we can rearrange that formula to solve any one of the other components. Then we have two other formulas that really aren't two other formulas. They're really the same formula, just rearranged. So we have a formula for the maturity value, which sometimes we'll call the future value, and that's that future value S is dependent on, again, the principal, the rate of interest, and the amount of time we've invested. Rearrange that same formula to solve for P, which is the present value or the principal amount, and we get the formula in bullet 4 there. The fun really begins in at the very end, where we start computing equivalent values and worrying about focal dates. This is where we get into the real life calculations. We've got one, let's say we have one arrangement for payment. For whatever reason, we have to do a redo. COVID hits, woohoo, right? Like that never happens, huh? So COVID hits, all of a sudden, our borrower can't make the payments that we originally agreed to, so we start to defer payments. Gosh, this sounds so 2020, right? We start to defer payments, and now we want to make sure that we defer those payments. We're trying to work, but we still want to make sure we get our proper return and get our money back. And so equivalent payments is sort of how we can. That unit really gives us a sense for how we go about ensuring that the new deal that we're renegotiating is at least as good as the old deal. So that last part, whew, that's 2020 stuff, that stuff. Okay, so that's really good material in there. So let's start off with the basics. What the heck is simple interest? There was a time, not to digress, this was part simple and compound interest was part of the Math 30 curriculum. My understanding is it's out. That is a travesty. So sad. But anyway, so simple interest is just the rent you are paid for borrowing, rent you pay to borrow capital. The rent is paid to you for lending capital. Right? Lending somebody $5,000 is no different than lending them an apartment you own or lending them a car that you own, right? You expect a return, you expect the payment back, you expect some sort of rent back when you loan somebody your apartment, right? Or somebody loans you the apartment, right? You pay rent on that. Well, somebody loans you money, you pay rent on that. So it's no different than that. That last bullet that you see on the slide, interest is based on 3 factors, blah, 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 all that verbal diarrhea. That's essentially I is equal to PRT. The wonders of math. Look at that. All those words in that last bullet there. And it's just all summarized by I equals PRT. Like math, it just sleeks it up. And now we just have to look at 4 letters instead of I don't even know how many letters are on that last bullet. So mathematical symbology, it makes our life easier. It does. It really, really does. So a couple of examples are listed on the slide there about examples of simple interest. Okay, so term deposits, short-term investments, GICs are a form of term deposit. Those are all involve simple interest. Okay. Other ones, Canada savings bonds when they used to be around were examples of simple interest. Maybe they come back Government is borrowing so doggone much money, they may have to squeeze it from everywhere. Short-term loans, again, simple interest. You typically get the interest payment or make the interest payment at the end of the loan. So you borrow $1,000, you pay it back in 3 months, and you give them $1,040 or something like that. Probably not that high. So we have that formula that we saw way back at the beginning with the objectives. And it just says that I equals to PRT. I is the amount of interest earned. And I want to really distinguish that from R, which is the rate of interest. Two different things, right? And that's where at the beginning of the Unit 3, when we were talking about percents and bases and all that kind of good stuff, really it factors into here, right? So that learning, boom, shows up right here, right away. Okay, so very important that you sort of have it settled in your head. So I is the amount of interest earned. P is the principal amount you start off with. R is the rate of interest. But note, it's the yearly rate of interest. Okay? Yearly. R is typically denoted in annual rates. Okay. Tradition, it's just easier, whatever, but it is. Okay? As a result of R being an annual rate, T, time, the unit of time is years. Okay, so we can have a fraction of a year on T. Okay, so that unit of time relates. If, for whatever reason, R was monthly, T would be in months. But typically, almost always, R is quoted as an annual rate. Therefore, T in this calculation will be the number of years. And so if the question asks us for the number of months, we may have to convert that T, which is expressed in years, into an equivalent amount of months or days or weeks for that matter. Okay? So we have that. And then the neat part, computing how long. How long is that T? And often that T is, how long between March the 12th and May the 15th? Heck, off the top of your head, I don't know, right? But that's important, right? If I loan somebody some money on March the 12th, they're paying me back on May the 15th. Well, how much interest should I be expecting on May the 15th? I need to know how long between those two dates. We have a function for that. It's called the days between dates function. It's both in the BA2 Plus, and I'll show you how to do it in the TI-83. Let's work on calculating the number of days between two dates. So let's look at, I'm recording this on August the 28th, 2020. 2020 has been kind of a sucky year, so let's see how many days before this 2020 nightmare is over. The 2021 nightmare begins. Okay, so I'm going to consider two dates. Today's date of August the 28th, 2020, and then the end of the year, December 31st, 2020. So I have a couple of ways to do this. And so I can start off with using my TI-83. Okay. So I have my TI-83, and I go and I start off with looking at apps. Okay, so you see this button here, apps, right? So I want apps. So I'm going to push apps. On that apps, one of the first things I see up here is finance. Okay, that's good. Finance is fun. And I click enter. Okay. And then I have a whole bunch of choices on the screen. Okay. I'm going to scroll up. I'm looking for DBD, Delta Bravo Delta. So I scroll up and I see on sort of point D, DBD, Delta Bravo Delta. And I push enter, and then I get this weird thing that looks, unintuitive. A DBD bracket. Now what the heck happens? Okay, so that August the 28th is written 08, because it's August, 8th month, dot 28 for the day, and 20 for the year. Note, no second dot. Calculators do not like numbers with 2 decimal spots. So 08 dot or decimal 2820. December is the 12th month, so it's 12.3120. Note I'm giving everything two numbers, okay? That's important. If it's not 2 numbers, then weird things can happen. So I punch in 08, assume you know how to do that, 08.2820. Okay, that goes into my calculator, comma, and then the next date, 1/12/3120, and then I close the bracket and I push enter. And I get 125 days. Okay, so 125 days from today's date until the end of the year. Okay, so we have that. So let's look at the BA2 plus. Function's very similar. It's a little bit differently arranged than the TI-83. TI-83 is much easier to work with. The BA2 plus maybe a little clunkier, but it's still, the basics are still good. Now, for the BA2 plus, I see above the 1 a little date button, a little date in yellow. Okay, above that, the number 1. So I'm going to go second 1, and I see DT1 equals to something. Okay, so I'm going to punch in the first date just like I did with the previous calculator. So I have 08.2820. Note, I kept the same format. Okay, the thing is that's going to be different here is I'm going to push the enter button at the top left. So I'm going to push enter and see where I see the little equal sign and I see the date represented. That means that has been entered into the registers on the BA2 plus. I'm going to push the down button, and now I see the second date, which I will now enter. 12.3120. Again, only 1 decimal spot. I push the enter up in the top left. I push enter. I see the equal sign. That means it's all good. I push the downward arrow one more time. I see DBD. That is not the correct DBD. I need to push this compute or CPT button at the top left. So one more button to push, the CPT button on the top left. Push that. Ha-ha! 125 days. Thank goodness they both agree, and we're all set. Just to reiterate one last time, and I know it gets to be grief. You try and listen to this on an audio clip or video clip, and I'm saying the same thing over and over again. It's just so that everybody is on the same page on this, is the time. Whatever R's unit of time is, T's unit of time is the same. Okay? And so sometimes R's typically will be an annual rate, so T will be in number of years, but saying, hey, this will take 0.185 years. Well, who the hell talks like that, right? I mean,
hey, yes, I'm thinking this looks like it's going to take about 0.185 years.
You know what? You'd start to back away even more than the 6 feet you have to. Somebody talking like that. So you sort of need to convert this into months and days. And the months, it's just, it's easier. There's 12 months in a year. So if you take the number of years, you multiply by 12, you're solid. You take the number of days, take the number of years, you multiply by 365, you get the number of days, okay? So that works and perfectly fine, and it keeps things really, really simple. Let's do some practice. Question 8. RMB equipment charged interest at 2% per annum. PA stands for per annum. It's Latin for per year. On overdue accounts, an invoice of $21,000 plus interest was paid 35 days past the due date. How much interest was paid? Notice the question. How much interest was paid. We really right now only have one formula for how much interest was paid, and that's the I formula. So it's I equals to PRT. Okay, so we have I. How much was loaned? $21,000. The rate of interest is 2%. We express that in decimal form because we're using it in a formula. And 35 days, because this is annual, it's 35 days out of 365, right? And 35 365ths. Run through, do the really simple math, and we get $40.27. Okay? But the key thing is the formula is pretty straightforward, but knowing which formula to use is the important thing. How much interest was paid? And that's what tells us that we need to use this I formula. Let's go to question number 16. Just to solidify things here. Question number 16. Mac's credit card statement included $360 in cash advances. Right, giving me an idea of what P is. $3.20 in interest charges. Okay, so I know what I is. The interest rate on the statement was 13.5%. For how many days was Mac charged interest? So I'm thinking I know T is probably going to be in years. So I'm going to have to convert that when I'm all done. So I was using the same formula as I did before. Okay, so that's constant. And I'm just going to rearrange it, right? I'm going to put everybody in there and then, rearrange it once the numbers are in. I think that's the easier way to do it. We have $360, which we borrowed. Interest was 0.135, and then T. Okay. Now what I'll do is I'll figure out the 360, divide both sides by 360 times by the 0.135, divide both sides by that, and I essentially get a T that's 0.0658 years. And again, nobody talks like that. And so I will multiply that by 365 days per year. Right? The years will cancel out. I'll be left with the number of days, and T equals to approximately 24.03 days. So about 24 days. Now people can understand that, right? 24 days, 0.0658 years. Nobody knows what you're talking about. Okay, so we move on. Next segment, computing future value. Sometimes future value is also called the maturity value. So you borrow some money, guess what? The lender wants you to pay it back. Hardly a surprise, right? So you will pay back the sum you borrowed, the principal amount, plus some interest. You got to pay the rent. Right? So you have two components to that. So as a result, when we look at what a future value is broken down into, it's broken down into principal component and an interest component. This is a key formula. It doesn't look like much. It doesn't look complicated, but it is essentially the foundation of finance math. Your future value depends on the principal and the interest. The only reason for the difference between the amount you borrowed and the amount you pay back is interest. That's all that's happening to this money. How much you start off with, how much you end up with, the only reason for the difference is the accumulation of interest or dividends or words to that effect, right? That's all that's happening here. Right? So we look at how much interest was paid. Well, I could figure that out. I look at, okay, how much did you get at the end? How much did you put in at the beginning? The difference between the two is interest. And we'll see this simple formula bounce up in annuities and in compound interest. And the formulas and the calculator work will be more complicated. But really, at the basic level, this S equals to P plus I. That's all that's going on here. It's no more than that. So we have a formula for I, right, the PRT, and essentially all we do is we plug in that formula for PRT, right? We do a little bit of factoring out the P, and we end up with the formula for the future value. But really, it all starts off with that S equals to P plus I. Substitute a calculation for I in there, and we have this formula for the future value. Okay, and that's it. Let's do some problems. This is the question from the text. This is question 6 in chapter 7. Prairie Greens Cooperative wants to invest $45,000, tell us what the principal is, in a short-term deposit. Okay, the bank offers 1.3% interest for a 1-year term and 1.1% for a 6-month term. Question A asks us, how much will Prairie Greens receive if the $45,000 is invested for the 1 year? Okay. So we're looking, so we think of our timeline here, right? We're going to put in today, so 0, time period, $45,000 in 1 year. We're getting some amount S back. Okay. So our S, we go into our mathematical toolbox and we see our S is the principal amount plus 1, and then in brackets 1 plus the interest rate is 0.013. And I'll keep in track your order of operations here. And 1 year is 1 year. And so there's what I'm looking at. I got to make sure that I do this multiplication here, the 0.013 times by the 1, then add it to the 1. And then that whole operation gets multiplied by the 45,000. So you can kind of see where it was kind of important to get a good handle on that Unit 1, Unit 2 stuff. If it's still a little fuzzy, go give that unit a look and then come back and retry it. Okay, I could show all the steps and I shy away from that, to be quite honest with you, so that you work it through. Math is like hockey or piano. You've got to really practice it to understand it. Watching me do it, all that happens is that you recognize, oh, hey, yeah, that's what you got to do. That's the right answer. And then you go on to the test and you go, Alan's not here. He's not answering the question. What do I do? How do I start? Where do I go? And it's a sobering when you start to think you're all alone with your thoughts on that. Okay, so work it through. See if that works out for you. Okay, so we've got that answer, and that's for part A. Now, part B asks, how much would Prairie Greens receive at the end of 1 year if the $45,000 is invested for 6 months, and then the principal and the interest earned is reinvested for another 6 months? Okay, so let's just do a little timeline here, and we'll just see what's going on. So we still start off with the $45,000, and then after 6 months, we take the that future value, which I'll call S1, and then we're going to reinvest all of that in for another 6 months, and we get an S2. There is a way to do this so you can combo it all up into one formula, and if that jumps out at you, by all means, that's fine. I'm just going to do it step by step, finding S1 first and then finding S2. Okay. So S1, okay, just my first future value. I start off my principal value of 45,000. 1 plus 0.011, different interest rate for the 6 month investment. 6 months is 1/2 of a year. Okay, so that becomes pretty important for me to put that in there. And then I end up with $45,247.50. The S1 becomes the new principal. So when I go to invest S2, what I'm investing in the second term investment is the $45,247.50. It becomes the new principal. $247.50, 1 plus, and again, interest rate still, we're going to assume the interest rate doesn't change. And right now in this current environment, that's probably a pretty good bet. And then I get that final answer is $45,496.36. Okay. And I'm all set. Right? So I've got B down. Everything's cool. Now C is a little bit more of an interesting one. Actually, B is pretty cool too, because you can kind of see the sort of compounding without really calling it compounding. So what would the 1-year rate have to be to yield the same amount of interest? So we're talking about a dollar amount, as the investment described in B. How much interest did we get in B? Well, I could look at that number and figure that out. If I start off with $45,496.36, and I start off with $45,000, and I end up with $45,496.36. What changed? Well, the $496.36, right? That's how much how much in interest I had. The only reason for why one grew, why the future value is higher, is the accumulation of interest. Back to that S equals to P plus I formula. So I want to be able to make $496.36. I'm still going to be investing the same amount of money. Okay. I have an interest rate, which is what the question's asking, and I'm investing that for 1 year, which is what the question asks. And again, I do a little bit of rearranging. I isolate the R. Practice that if you're unsure. And I get an interest rate very close, but a little bit higher. And that's where we start to see the effect of that compounding. So that little 0.03%, that's the impact of the compounding right there. Okay. So that is awesome. Anyway, thank you very much.